our ecosystem is exploding, and actually we are now in the state of integrating many QPUs into our system. So it's been
Sorry
a
to
bit tough.
interrupt, guys. Sorry to interrupt. I guess Jitesh is here as well.
Yeah,
Hi,
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 Jitesh.
Jitesh. Hi.
Vishal, hi, Ruth. Hi, guys.
Hi,
Hey,
Jitesh.
Jitesh.
Hi, Aditya.
So, Ruth, the session is upon you. You can start in 2 minutes.
Yeah.
Okay. We'll all go on mute and we won't disturb you guys.
But
Perfect.
yeah,
Thank you.
yeah. And anybody in the guest list, feel free to write the questions and such, and we'll hope to address it at the end of the session.
Ruth, you can start. Jitesh, you can turn on your camera and mic.
And the recording is going on. Great. Thank you everyone for joining us in this auspicious event of advancement in quantum, where we're looking at the roadmap to commercialization. And also, happy World Quantum Day to everybody. We're very excited to have all of you guys together. We have a great panel session lined up here today. And to kick off the first session, where we would be talking particularly on the aspects of really trying to figure out where quantum is and how we're looking to bridge the gap between the technical aspects of quantum, the challenges that are really the majority of the companies are facing. And so to quickly introduce the two panelists for this session, firstly, Jalal. So Jalal comes from a strong business development background, being the business development manager at a leading software company, software portfolio management company, Software One, before joining QMware. And at QMware, he's the VP of Sales and Partner Management at and he recently joined at that position about 6 months ago. And QMware is a joint venture of Terra Quantum and Novarian, where they're looking to develop unprecedented hard and software, which brings us step by step closer to our goal, to the goal of data center, which outperforms human thinking. They're really looking at the next level of how do we go from where we are right now to the next stage and solve those really extremely challenging, complex problems that humanities as a whole were facing. Jalal and I have been connected for almost a year now, and it has been fantastic to interact every chance I get. It's lovely to interact with him and definitely learn from his vast experience as well. So please welcome Jalal El Yusuf. And
Thank you, Ruth.
secondly, yes. And secondly, Jitesh, we cannot see you. If you could unmute and also, if
Okay, can
possible,
you hear
turn
me?
on the camera. Yes, now I can hear you.
Okay,
And if you
can
can
you see
also,
me?
I cannot see you.
Okay.
Your camera is turned off.
No, it's on, but it always happen during a meeting, no?
Yes, I mean Teams. it's not even just Teams, it's the whole thing about virtual. But hey, I mean, we'll always get through the technical challenges and such. But allow me to introduce Jitesh. So he's the founder and CEO of Artificial Brain. And Jitesh, bringing his strong background in software development and consulting into quantum computing, he created this venture, Artificial Brain, which focuses on helping businesses to solve complex optimization problems, including location optimization, problems with minimal expertise, time, and cost. Artificial Brain graduated from Quantum Startup Foundry by University of Maryland and Accelerator by University of Maryland, and then has been rapidly growing in the last few months. So please welcome Jitesh as well.
Thanks, Ruth.
Jitesh Lalwani.
Am I visible now? Ruth? Can you see me?
Unfortunately, no.
Okay, I don't know. My camera is turned on. Maybe let me rejoin quickly.
Yes. Okay. So I guess while Jitesh is joining, let me actually start off this panel by kind of asking you a couple of questions regarding this the what we're really going to be talking about. The challenges that are currently faced by businesses, especially of quantum businesses, in implementing their quantum computing into their existing systems and workflows. How can these challenges be addressed? So why don't you kick us off, Jalal?
Yeah, well, first of all, thank you very much for the very nice introduction. I couldn't have made it better actually than you. Thank you very much, and you are also a very impressive person. The first time I met you, I thought I'm going to meet some crazy professor, but then I saw this young, humble guy that is striving in such disruptive technology and creating beautiful things that will change the shape of this planet. I'm 100% sure of that. In order to answer your question to the challenges that businesses face today in implementing quantum computing, there are actually two aspects that we identify in this area. The first one is the infrastructure aspect, where you need to integrate native quantum processors into your existing infrastructure, which is a bit complicated at the moment for some topologies, if we think of superconducting and the cooling. But the easiest way actually to access quantum computing is over the web. Companies like ours, like QMware or other hyperscalers, offer a very easy access and and we offer like more access also to native quantum processors, not only to the simulated versions that we have created. Yeah. So this is the first part, and the second part is the software development part, and here. Actually, the most important part is the skill set in order to deliver executable quantum algorithms to solve the tasks needed. So in order to close this gap, you can either train your software developers. Actually, when I started working at QMware a year ago, this was one of my first questions is how to turn Java developer or C# developer into a quantum-based developer, and they told me, well, they need linear algebra. This is the first thing, and the second thing is, of course, he doesn't need to be a physicist, but he needs to understand the physics behind it. So this could be also an obstacle, but we have seen also a lot of companies like Classic that actually took a complete different approach on that. They have a no-code or low-code approach. So you don't need to be a quantum physicist or a computational physicist in order to write quantum applications. It's as simple as that you just go on Classic or such of these platforms in order to develop your quantum-based algorithms. This is one part, or the other part is if you actually consult with like a quantum specialist, like Terra Quantum, like our sister company. They will support you actually during the whole software development cycle. They will support you from the analysis of the applications to the POC and then to the deployment of the application. Does this answer your question?
Yes, yes. Thank you. Thank you again for kind of developing this. And let me also give another a chance to for Jitesh as well. So yes, Jitesh, the question that what we're really talking about is the challenges that are currently faced. And perfect, now we can see you as well. The challenges that are faced by businesses in implementing quantum computing while utilizing existing systems that are out there. So what are the challenges that you face from artificial brain, and how have you been able to address those challenges individual, like for the company, as well as for some of your customers when you're talking with them as well?
All right. So first of all, thank you for inviting me for the panel today. So, and a happy World Quantum Day to everyone who has joined today's session. So, if I talk about challenges, right, from business perspective, I think the biggest challenge is that they don't understand quantum, right? It's still at an early stage. If I go and tell them, hey, I am a quantum computing software company, they will ask me, what is quantum computers, right? We don't understand. So there's a lot of education that is required, right? So in each of the deck that we present to our customer, the first two slides are to explain what are quantum computers, right, and what they can do. Right, this is the biggest challenge of awareness, and this is true for any new technology. Let it be quantum, let it be AI, let it be blockchain, right? So it is always true for any technology. The second challenge is the identification of the right use cases, right? So where quantum can have a big impact, right? This is we all quantum companies are at a use case discovery phase where we also don't know where quantum can be useful, right? So we have to do a lot of R&D, connect with many customers, understand their problems, and then as a company need to decide which are the right quantum use case. And those use case should not only sound cool, right? They should have business impact. For example, if I go to some customer and tell them, hey, I'm going to develop this quantum software for you, they don't understand that. But if I tell them, hey, this is going to increase your revenue by 20%, right, then they understand. So we need to talk their language, right? The third and obvious thing is not just true for quantum, but this is for other technology as well. The lack of expertise, right? The lack of talent. And for quantum, it's a very, very big challenge because quantum is just starting, right? And if you see the programming, even it is, even though it is Python, a programmer needs to understand a lot of new things, mathematics, what is cubo, what is this gate, what is this circuit, right? So even for me, it was very, very hard to come and learn quantum. But if let's say some fresher is starting, it's obviously very difficult for them. So I believe these are the three topmost challenges with not with our company also, but in general with other companies and with our customers as well.
That's the last point that you mentioned, and very similar to the point that Jalal also mentioned. I want to highlight this aspect of bringing the existing workforce that is there on classical computing and upskilling them to adapt into the quantum computing aspect. And there are very critical points that the upskilling, in order to, for the upskilling to be happening successfully, there are very technical things that the individuals, the developers, and the scientists, researchers need to be able to understand. And so when we are looking at from that mindset, how has each of your guys' organization incorporated very academia findings and a lot of research that is happening in academia and integrated that into your specific products or offerings as well? Because there is a quite a big jump that's in the academia versus especially in the technical information technicality versus somebody coming from classical computing. So how have you been able to address that? So yeah, Jalal, if you would like to answer that first.
So if I understood your question correctly, so how do we actually address academic research and quantum computing? Yeah, well, what we do is we do a lot of funded projects. So what we need here is a lot of government spending and investor-driven academic actually research as well. Yeah, we are currently developing the German quantum cloud together with Fraunhofer, which is one of the top research and development organizations in Germany, together with the University of Stuttgart, their Professor Leimann, and Ionos as our infrastructure partner. And the aim of this funded project is actually to build a quantum platform for the German small and mid-sized industry by offering access to a large set of use cases based on, of course, quantum computing and delivering quantum computing know-how to these companies. Because as Jitesh said at the previous question, when you go to customers today, or when you go to anyone that is not acquainted somehow with quantum computing, you have to start by um, explaining how the classical processors function and how the quantum processors function, and what the difference is between a deterministic system where you have one or zero, or where you have a state which is between the one and the zero. So you need to enable these companies, these individuals, in order for them to understand what the impact of quantum computing means to their organization, means to their applications, and where they can enhance their tools and to get the best performance out of it. So with this project that we are doing, we are actually interacting with a lot of small and medium-sized companies, industrial companies in Germany. And what we're trying to do here is the enablement of the quantum tech for the German industry. So this is one of the approaches that we do actually. And we are also, uh, um, as a partner manager here at QMware, we're also partnering up with a lot of universities and research institutions, and especially with the universities, we give them training. We have special offerings for the universities in order to access our hybrid quantum cloud and to use different kinds of topologies as well. So this is our approach. Jitesh, you want to take it from here?
Yeah, thanks, Jalal. Um, See, one thing is very clear. Yeah, so this is an R&D field, right? You need a lot of collaboration with universities, right? It is not
Mhm.
an mobile development where you will just develop a page and that's it. Here, when you start with an application, you need to do a lot of R&D, right? So to do that,
Mm.
obviously, it can't be done in silo. So what we as a company are doing is we are doing MOUs with either universities or directly with professors, right? So in the past, we have signed MOU with the Christ University, and now we are also working with Dr. Mandar from Symbiosis University. Yeah? So we understand it requires a lot of collaboration. In fact, I have conducted a technical seminar yesterday at Triple IT Delhi, and there also we discussed how we can collaborate with them. They have a separate R&D department, right? And I was surprised to see in a positive way that the students, the work that they are doing, the R&D that they are doing is of top quality. They are using Qiskit Pulse to directly interact with the hardware to create new architecture and so on, right? So these kind of R&D we require, these kind of students or professors who are doing lot of work in the quantum. We need to do lot of collaboration, and that's the reason we are trying to sign MOUs and onboard professors as much as possible.
Okay. That's fantastic to hear, Jitesh, because this close collaboration is definitely the way to move forward, whether it be with organizations and academia, or even between
Mhm.
organizations, as we've seen fantastically been done through essentially a lot of the quantum organization. There is not a lot of competition that is happening in between the quantum companies. Rather, it's more about let's work together, and that mentality. It really elevates the quantum and differentiates the quantum field from any other field altogether.
Yeah. So
And so that's yeah.
just to add one more point to this, many startups are actually co-founded by professors, right? If you
Yes.
see many
Mhm.
quantum startups, they are also teaching, and they are also are co-founders of quantum startup, right? So without the collaboration with universities, this field is not going to succeed.
For
You're
sure.
absolutely right. Actually, I can share that as well. That Marcus Flitch is a physicist. He's the CEO of Terra Quantum. He's our CEO as well. And George Gesek is also his, we call him Quantum George. So he's all of these companies, all of the quantum-based companies have some physicist background, all of them.
Right, right. And there's
Uh,
like a close bond that I
Absolutely.
love to hear. Yeah, there's this
Yeah.
close bond. I love the fact
And,
that we have in the
and
quantum ecosystem.
exactly. And Ruth, you said also one thing that is actually it's stunning to see because, as you said, I came from the classical IT. So I was dealing with, I don't know, Microsoft, with those big five. And there is no collaboration between the big tech companies.
Right.
But what we see here at the quantum society, that there is a quantum society, we are all working together. We know that the market will be here.
Exactly.
It will ignite. And we're all working closely together. We don't see any other companies like Strangeworks is also here today. We don't see them as our competitors. We see them as our partners in crime because we want to engage in this quantum journey with as many companies as possible and to build up our network here as well.
No, for sure, for sure. And to wrap up this session, I do have one last question for both of you. So we talked on the collaboration and on that side, but then I want to kind of get your guys' view on what are the some of the most promising industrial use cases that you see that can be applied for quantum computing, and both of you guys kind of mentioned or at least preface that a little bit, and how can companies and organizations leverage these opportunities as well. So Jitesh, if you'd like to start us off.
Yeah, thank you. So I will talk about two industries in which we are working, right? The first is space industry, right? So we believe that because space is a very complex domain, right? The activities are very complex in nature. We believe that quantum can have a very, very big impact in the space industry, right? So if we are talking about space economy, it can't be done without quantum. Now, there are several applications of quantum. If we talk about quantum sensors, quantum communication, and the area where we are working is quantum optimization, right? So we have already developed a quantum software to optimize the scheduling of Earth observation satellites, right? And we are getting in touch with several agencies, and they are and we are demoing and we are showing them demonstrating our software, and they are really liking it, right? So we believe that application especially for Earth observation, I think this would be a very, very big deal in future. The second, if I talk about energy, as we know, energy companies are facing this problem where they are uh, transitioning from fossil fuel to renewable sources. So the complexity for them has increased multifold, right? And in the past, they used to generate energy from one single source, centralized source. Now it's distributed, and now you have something called as prosumers, where your consumers are becoming your producers, right? So uh, it is becoming really difficult for energy companies to handle this complexity, and we again believe that quantum can have a very big impact on the energy sector, and we have developed a quantum software which is to select the right energy sources, which we call as energy mix optimization. So this software helps energy companies to select the right energy sources. For example, it could be either solar panel, it could be wind turbine, it could be fossil fuel. So the software will try to meet the energy demand at a minimal cost, and it also helps to basically meet renewable targets, right? So these kind of application, we believe that would be early adopters, and company can really benefit from these kind of applications.
Great, great. Jalal, what are applications that you guys have seen at QMware?
Well, I actually have to say that it's more or less the same applications that you, Jitesh, are doing. We're doing the same thing also with Terra Quantum. So we have satellite vision planning with Thales. We have energy consumption and projection with Uniper in Germany. What we actually see, or the most of the promising areas actually for quantum is optimization, simulation, machine learning, AI, and quantum cryptography. So all these fields are the most promising fields that will change actually the world here as well. Yeah. So let me give you an example. We did actually a project with um, with a logistics company. So it's an international logistics company, and we try to help to optimize their route planning to reduce empty mileage. You have to imagine that this is a company with over 6,000 trucks, lorries. So they have a huge fleet that they are using, and almost 30% of the truck miles driven are actually empty. So they needed to lower this percentages, and each and every digit of this percentages is actually a couple of million euros. And they really love their euros, and they said we're spending too much money on that, and it's bad for the economy. It's bad for a lot of things. So they asked us actually to optimize the route planning, and we were able to enhance their scheduling by quantum-based algorithms. It was actually Terra Quantum that did this project. So what they did is they analyzed the whole software stack that they had, and they actually sliced the applications more or less. They checked which parts needs to be optimized. They optimized them. They did a lot of proof of concepts in order to optimize it really to the maximum. And at the end, we were able to lower that by some percentage points. And this is actually one of the real world use cases that we always use to actually address our customers too. So with that, we could reduce the fuel consumption and improve also the traffic forecasting as well for this company. So it's also amazing.
Right. No, that's great to hear. And what I will say to this as well is that from what we have seen at Bozanki side, it's a lot of the leading traditional innovative companies. Our target market is automotive, aerospace, manufacturing, and such. And a lot of the traditional companies, obviously, they're there at the brink of new innovations, so they will be there in quantum.
Mhm.
What has been surprising for us to see is that there are companies who a traditional personnel might not necessarily that's not the first company that would come to their mind, especially looking at such an innovative company, innovative technology of quantum computing. So there are in some essence some dark horses, and I feel like that will be kind of there for throughout the all different industries as well, where of course you'll have the leading organizations, but then you may have those specific domestic based or a single nation or maybe multi-nation organizations. They're quite small, but they want to kind of go to the next level, and therefore they're looking
Absolutely.
at these new innovative technologies. So that's actually quite refreshing to see, especially being from quantum industries ourselves. So I do want to address a couple of questions from the audience as well. So the first question
Maybe
yeah,
maybe I can add one more thing to the whole
sure, go
thing.
ahead, please.
We have many customers also from the public sector that are addressing us, because what they need is secured lines. So quantum key distribution is key here to this situation. We have another problem, which is steal data now and decrypt it later. Once we have the right amount of quantum volume, we will face big problems, all of us, not only big companies and public sectors and so on. Once these keys get broken, we all have problems. So we need also to think about the post quantum era. So it's not only to optimize things and to run simulations and to optimize also machine learning, where machine learning actually in the learning phase, it's up to 10 times as fast. The execution is still classical.
Right.
But yeah, but these are the things that we can share with everyone here. Yeah?
No, for sure. And I think these are
So,
quite important areas in where quantum computing can readily showcase advantage over classical and these niche fields. So yeah, one of the questions that I do see from Somik Chakravarti is what advice do you have for someone who's transitioning from classical technology field to the quantum computing field? Uh, Jitesh, if you'd
Hitesh?
like to, yeah.
It's going to be tough. It's going to be difficult, right? You need to learn a lot of mathematics, right? For sure. Obviously, for the starting days, it's going to be tough. But if when you start developing a quantum application, right, you're going to enjoy it as well, right? So my suggestion is to go to Qiskit website, learn about
Mhm.
Qiskit, and then you can also go to D-Wave website, learn about quantum annealing, so that you understand both of the ways to develop quantum applications.
Exactly. I would
Okay.
just say the same thing because, like, if you go on the Qiskit site, I mean, it's not our competitor, but it's also a quantum computing. I mean, it's this is the giant of quantum computing. Yeah. So they have a very
Right.
nice learning path. Actually, you start with the small gate-based developments, and then you just go through the whole development cycle. Actually, so IBM
Okay.
has mastered that. Yeah.
Great, great. And I do want to ask this one last question. I actually like this question quite a lot. So, any resources that has helped you with business storytelling? Because as we know that in business, being able to actually explain and really, showcase to people the aspect of quantum computing, breaking down the technical into rather elementary, using elementary vocabulary and such. So, what resources helped you with the business storytelling for quantum computing to your specific customers or clients?
Okay, so
Yeah.
I
Well,
think,
uh,
yeah, Jalal.
Yeah,
go ahead, Dodo, please.
yeah,
Yeah, I think the biggest learning resource would be life, right? Uh, it will teach you, right? And especially when you go to customers and when you do a bad job, right? You will on your own start learning, right? So I don't feel like there could be any better learning resource than going practically and try to explain your potential customers, right? What is quantum? And
Yeah.
this is not just a problem with us, right? So I was seeing a video, an interview from Steve Jobs 40 years ago, right, where he was explaining what is the difference between classical computer and business computer. And now we are exactly doing the same thing. We are explaining what's the difference between quantum computer and classical computer, right? So
right.
I don't think there's any better resource than to go to customers, pitch them, first of all understand their problems, right, which is very very important, and then pitch them how quantum can be useful to them. Yeah, Jalal.
Right.
Yeah, well, if actually if we go one step back and address someone who doesn't have any clue about quantum computing, and I will take myself here because like a year from now, like in the past, my quantum knowledge was based on Star Trek for quantum torpedoes. So I didn't really have any knowledge about that. We have a very cool physicists at our company that explained it in a very, very nice and easy way. And the other thing was that I got myself a lot of books and read a lot. Some of these books I didn't really understand, but by time more and more puzzles are just coming to fit together. And the other thing is YouTube. On YouTube, you will find tons and tons of materials on how quantum is maybe explained in a very, very easy way in order for everyone really to understand and to jump on this technology.
Right, right. And I definitely, kind of share both of your guys' view on this because we've kind of done it the hard way, trial and error. And because as we know, we all know that quantum is a new field, but definitely, I would have to conclude this session. It was a very quick panel session, but it was a rather refreshing one at the least. So thank you again, Jalal and Jitesh, for coming here. And yeah, please do stay around for the next session, which is going to be led by Aditya. So yes, thank you again, guys.
Thank you, Ruth.
Ruth, thank
Have
you,
a
and
good day.
Chitesh, thank you as well. Bye bye, ciao, ciao.